Welcome to JSM Learn. Now we are going to solve previous year JEE Main questions from the chapter Sequence and Series, and the topic is Arithmetic Progression. Here comes the first question. The question says that set A containing 101 terms of AP, and the first term is A and the common difference given is 5. In set B, 71 terms of AP and the first term is 9 and the common difference given is 7. Out of this set A and set B, we need to find the common elements, that is nothing but A intersection B, and out of this A intersection B elements, we need to find elements which are divisible by 3. So we have noted down given data, and next AP general terms are in the form of A comma A plus D comma A plus 2D comma A plus 3D and so on. Nth term of AP can be written as A plus n minus 1 times D. A is equals to first term of AP, D is equals to common difference, n is equals to number of terms in given AP. So we'll write number of terms in AP, that is nothing but one terms, we are going to write 1 by 1. So set A is equals to first term is 1, second term is 1 plus 5, that is nothing but 6, next term is 11, next term is 16, next term is 21 and so on. We are going to write last term of set A, that is nothing but 101th term in set A. By substituting A is equals to 1, n is equals to 101 and D is equals to 5, we will get the last term of this set A, that is equals to 501. We are going to write set B similar to set A. How we calculated the each term in set A, we are going to do the same thing for set B also. The first term is 9 and the second term is 9 plus 7, that is 16. Next third term is 23, next 30, next 37 and so on. We are going to write last term in set B, that is 70 first term. We are going to substitute A is equals to 9, n is equals to 71 and D is equals to 7. So the last term is 499 in set B. So we are going to write now A intersection B. This is also a AP. A intersection B means common terms to set A and set B. We are going to write it in a single set. So this set also forms an arithmetic progression with the first term is 16. By observing both sets, set A and set B, we can say the 16 is the first common term to the both sets. So that we will take it as A common is equals to 16 here. So how to find out the common difference for this A intersection B? That is nothing but D common, right? By doing LCM of given two differences of set A and set B, that is nothing but 5 comma 7, we can obtain our new common difference, that is equals to D common is equals to LCM of 5 comma 7 is 35, right? So we got our D common, that is equals to 35 and A common is equals to 16. So now we are going to find out number of terms that are there in A intersection B. So in A intersection B, we got to know that A common is equals to 16, D common is equals to 35, right? And AN, that is nothing but last term of A intersection B should be less than or equals to 499. That is the last term in set B. So we have chosen 499 as our maximum possible term. So by an formula, a plus n minus 1 times d. Here it is a common plus n minus 1 times d common should be less than or equals to 499, right? A common value is 16 plus n minus 1 times d common value is 35. That should be less than or equals to 499. N minus 1 times 35 is less than or equals to 483. N minus 1 value times 35 should be less than or equals to 483, right? So this and this will get cancelled for a 13.8 times. So n minus 1 is equals to 13.8. N is equals to less than or equals to 14.8. So now here n belongs to what? Natural numbers, right? So we are going to choose a natural number that is less than 14.8, that is equals to 14. So this n is equals to 14 denotes number of terms in A intersection B. So we are going to write each term in A intersection B using the formula an is equals to a plus n minus 1 into d. By substituting n is equals to 1 comma 2 comma 3 comma 4 comma up to so on so 14, we can write the each term in A intersection B. So these are the 14 terms that are there in A intersection B set. Now we are going to find out of these 14 terms which are also divisible by 3. So first we will see divisibility rule for 3. Divisibility rule for 3. So sum of digits equals to multiple of 3. Then only those numbers are divisible by 3. So 1 plus 6, 7 is not divisible. 5 plus 1, 6 is divisible. Next 8 plus 6, 14 is not divisible. 121, 4 is not divisible. 1 plus 5 plus 6, 12 is divisible by 3. Next 191, 11 is not divisible. 10 is not divisible. Next 9 is divisible by 3. Next 296, that is nothing but 17, not divisible. Next 331, 7 not divisible. 366, 15, it is divisible by 3. Next 401, 5 is not divisible. 436, 13 not divisible. 471, 12 is divisible by 3. So out of these 14 terms we got 1, 2, 3 and 4 and 5. So 5 terms in A intersection B that are divisible by 3. So we got 5 terms from A intersection B which are divisible by 3. So our answer is B. Now we will see some similar questions asked in the previous JEE Mains in 2024 and 2023 and 2022 about the similar concept of this number of common terms for a given 2 arithmetic series. So here the question is about 2 arithmetic series is given, and out of this we need to find number of common terms. And in second question we need to find 8th common term of these 2 arithmetic series. Next in third question we are going to find the number of common terms, which means A intersection B, what we have did in our question, we are going to do the same, and here we are going to find the sum of terms in that A intersection B. Let's see the next question. Sum of first n terms of AP is equals to 3n square plus 5n. Then we need to find the sum of the squares of first 10 terms of AP. Given sum of n terms is equals to 3n square plus 5n. We know sum of n terms is equals to n by 2 times 2a plus n minus 1 into d, which is equals to n by 2 times first term plus last term. We can write nth term of AP as a plus n minus 1 into d. We can also write nth term of AP as sum of n terms minus sum of n minus 1 terms. So from this formula, we'll try to write the nth term of AP, Sn minus Sn minus 1. So we know direct sum of n terms, that is nothing but 3n square plus 5n. Now we need to find sum of n minus 1 terms by substituting n minus 1 in the place of n. That is nothing but 3 times n minus 1 whole square plus 5 times n minus 1. On solving this, 3n square plus 5n minus times 3n square minus 3 plus 6n minus 5n plus 5. So here minus 5n and plus 5n will get cancelled, 3n square and minus 3n square will get cancelled, and the final nth term of AP is equals to 6n plus 2. So we got nth term of AP. Now we are going to find the sum of the squares of first 10 terms of AP. That is nothing but a1 square plus a2 square plus a3 square plus a4 square plus up to so on so a10 square we are going to find in this question. So this can be represented as sigma running from n is 1 to 10 an whole square. Sigma an square n is running from 1 to 10 terms. Sigma 6n plus 2 whole square n is running from 1 to 10. We'll expand this 6n plus 2 whole square first. That is nothing but 36n square plus 24n plus 4. n is running from 1 to 10. Now we'll split this sigma to the each terms. Sigma 36 n square plus sigma 24 n plus sigma 4. n is running from 1 to 10, n is running from 1 to 10, and n is running from 1 to 10 here. So this can be written as 36 times sigma n square plus 24 times sigma n plus 4 times 10. So we know sum of squares of n terms is equals to n into n plus 1 into 2n plus 1 by 6. And also sigma n means sum of n natural numbers, that is equals to n into n plus 1 by 2. Here n value is 10, right? We need to find up to 10 terms. So we can directly substitute in the place of n, which is equals to 10. n into n plus 1 into 2n plus 1 by 6 plus 24 times n into n plus 1 into by 2 plus 40. So by substituting n is equals to 10, this will become 36 into 10 into 11 into 21 by 6 plus 24 times 10 into 11 by 2 plus 40. On solving this, we will get 15220. In this question, first term of AP is 10 by 3, number of terms in AP is 30, and sum of all terms of AP is equals to cube of the last term. We know that nth term of AP can be written as A plus n minus 1 into D, and sum of n terms of AP is equals to n by 2 times 2A plus n minus 1 into D, and also we can write sum of n terms as n by 2 times first term plus last term, that is nothing but n by 2 of A plus A n. So it is given that Sn is equals to an cube. By using this formula, we'll write which is equals to n by 2 times A plus an. Here n is equals to 30 and A is equals to 10 by 3. We'll substitute here n value and A value. An cube is equals to 30 by 2 times 10 by 3 plus an. So we'll write all these terms on one side. An cube minus 15 an minus 50 is equals to 0. It is a cubic equation in an. So how to solve this cubic equation? I'll take hit and trial method for this. So now I am assuming an is equals to 5. So how I got the thought to take an is equals to 5? By observing the coefficients of cubic equation, I got to know that these are the multiples of 5. That's why I assumed that an can be 5. So we need to check whether it is correct or wrong by substituting in cubic equation. So we'll check by substituting this in the cubic equation. An cube minus 15 an minus 50 is equals to 0, right? We assumed an is equals to 5. So we'll substitute this in our given equation. 5 cube minus 15 times 5 minus 50 should be equals to 0. 125 minus 75 minus 50 is equals to 0. So here we got 0 is equals to 0, which is satisfied in our given equation. So now from here we got to know that an is equals to 5, which is equals to last term in AP series. That is nothing but number of terms in AP is equals to 30, right? And A is equals to 10 by 3. So we know the formula an is equals to A plus n minus 1 into D. We are going to find this common difference by substituting A value, n value and an value. 5 is equals to 10 by 3 plus 30 minus 1 into D, which is equals to 5 minus 10 by 3 is equals to 5 by 3, that is equals to 29 times D. So from here D is equals to 5 by 87 we got. So common difference of this given AP is 5 by 87. Thank you.